In this video, I'm going to give you an example of integration by parts. So the integral we are trying to simplify is integral x e to the power negative x. As you probably know, the integration by parts formula is integral u dv is equal to uv minus integral v du. Now here we make the assumption that u is equal to x and my dv is equal to e to the power negative x dx. This substitution has to be done properly, otherwise you will run into problem. And it's not too hard to figure it out. If you run into something that's kind of not solvable or it's hard, you're having hard time solving it, then maybe you should try the other way around. All right, so u is x and dv is e to the power negative x dx, then du over dx is equal to 1 or du is equal to dx. Now we are going to integrate the dv. Integral dv is equal to integral e to the power negative x dx, and integral dv is just v is equal to integral e to the power negative x is e to the power negative e to the power negative x. Now we are going to go ahead and substitute these values. So our integral x e to the power negative x dx is actually going to be integral u dv, right? Which is uv minus integral v du. Now let's go ahead and plug in the values for u and v. U is x, as we assumed right here, and v we found out to be negative e to the power negative x, then minus integral v negative e to the power negative x, v is negative e to the power negative x du, but du is dx. And if I simplify it, I get negative x e to the power negative x, and then this negative and negative is going to make it positive, so integral e to the power negative x dx, and we get x e to the power negative x integral e to the power negative x dx is negative e to the power negative x. Then we introduce the arbitrary constant c. Now this is how you would solve an integral problem by using the integration by part. I hope that this discussion was helpful. Thank you very much.